There we go.
How about now? All right.
Perfect.
Okay. Well, I appreciate the opportunity to speak with y'all today. And I'm Trap Puckette with RPS. RPS is a multidisciplinary consulting firm. And the group I'm in is in their MedOcean group. And I'm based in Charleston, South Carolina. We focus on oceanographic data collection, primarily currents and waves and water levels and things of that nature. And the project I'm going to talk about today is a project we've been doing for the City of Norfolk for approximately the past 15 years, a wave monitoring project that has been used to support a number of their coastal projects that we'll talk about here for a moment. Just want to make sure y'all can hear me now and everything's going good. Yeah. Okay, good. So the Norfolk is located on the lower portion of the Chesapeake Bay, and back in early 2000, they started a large-scale revitalization project of what they called the Ocean View area, which is shown in that yellow box, and is that section of the coastline had over the years experienced a lot of erosion, and the city was looking to do a major revitalization project there, and as part of that, they realized that they needed to look at a kind of a long-term beach management and protection was going to be required there. And for that section of the coastline, a lot of the coastal processes were driven by the local wave and currents in that area. And there had also been a lot of damage associated with some large storm events that had occurred over the years, but were poorly characterized. Historically, for that section of the Chesapeake Bay, the data that had been used for modeling was actually offshore wave data that had been transformed into the Chesapeake Bay and then used in the different modeling processes that were undertaken, and that had not proven to be very successful. It was kind of recognized that modeling approach was not working very well. So as the City of Norfolk undertook this period of construction, they decided, well, let's go ahead and invest in some real wave measurements and currents, and that was going to be necessary for this project. So so the city went ahead and they committed to this long-term monitoring program and started looking around for some different options. They wanted something kind of simple, robust, did not need a real-time system, and ultimately they ended up selecting the Nortek AWAC, and they ended up purchasing one, and the arrangement was that they purchased the equipment, and then RPS, we ended up designing the installation system, and then we installed the system and serviced it and analyzed the data, and then provided that data to the City of Norfolk's coastal engineering consultant, Moffatt Nichol. And so initially, when the project started out, we set out to do a 3-month servicing of the instrument. After, I think, about 2 years, we realized that it would be possible to extend that to 4 months and save the city some money, and we're able to still get the same quality of data. the instrument package, the way we deployed it was in one of our trawler-resistant bottom mounts, TRBMs, and you can see it on the left slide is a picture of the AWAC mounted on a grate, and then you've got the battery pack, and then for recovery we use an acoustic release system because we try to stay away from divers. For those of you that are not familiar with the AWAC, it has 3 angled acoustic beams that are used to measure current velocity, and then a 4th vertical beam, which you can see on the instrument, and that does a direct measurement of the sea surface, and it's, I guess, analogous to the echogram that was talked about in the previous talk. So, the middle beam is, like I said, providing this direct measurement of the surface. So we put these out, and they all look nice and bright and shiny when you put them out, and then upon recovery, you get a lot of biofouling, and that kind of was one of the big challenges at this site. As you can see in the lower right-hand picture, had some pretty prolific oyster growth there, which was good to see. This was kind of one of the more recent recoveries. When we during our early years of the deployment, one thing that was interesting is we didn't see much growth at all on the instruments, but then over time, particularly of oysters, but in more recent years, we've seen a lot more oyster growth, and hopefully that's an indication of the recovery of the oyster population in the Chesapeake Bay, which has been an ongoing project for years. So good for the oysters, bad for the instruments. So what we were getting out of these systems was directional wave spectra every hour, and then current profiles every 20 minutes. Our experience with this system over the past 15 years has been very robust, and we've had a really high rate of data return, over 93%. And some of that period of when we don't have data was actually a couple of gaps where we had to pull the instrument to get some work done on it, and so it just wasn't in the water. The failures that we've typically seen have been related to the cables or the connectors, and or a battery issue. So the instruments themselves have actually held up very well. During the time period of this deployment, we've captured a number of tropical systems that have passed over the site, and then as well as several really high wind events with getting 50 knots plus, and some real big storms with big waves, and that's been kind of really important to assess the performance of some of the different structures that have been built by the city. Here's an example of the waves during Hurricane Ernesto, which passed over the site in September of 2006. And it kind of highlights the importance of why we were collecting this data in the first place, is that if you can see up in the directional wave spectra, there are 2 basic peaks in the wave spectra. You've got one towards the north, and that's associated with wave energy that's being generated within the bay, and because there's a large fetch to the north of the instrument, and then another peak which is coming more out of the east, and that's wave energy that's coming in from the Atlantic Ocean. So you've got these 2 separate peaks in the wave energy spectrum, and they're both having a very significant impact on the wave climate on this section of the coast. And so it's kind of one of the main factors for why this actually collecting the data was important. Here is just a summary table of the average wave heights we've seen at the site since 2006, and as you can see, as you might expect, the highest waves were occurring in September, October, and November. Interestingly enough, they drop off in December, which I'd always thought was interesting, but you kind of get a lull there before you get back into springtime when the wave energy picks back up. And then as you get into summer, the summer months, June and July and August, the wave energy drops off as you would expect during kind of the pretty benign wave condition months at the site. One of the things that's really nice about the Nortek software for processing the wave data is that as you go through the wave processing process, the software will give you an error code if it runs into an issue in the analysis. And this table just kind of highlights the different error codes that occur and what exactly they mean and how often we encounter those error codes. Several of the error codes are just associated with the fact that there's kind of hardwired into limits to the or to the analysis, and if you exceed those limits, which will occur periodically, the analysis just kind of blows up for one reason or another, then that data, the data from that particular analysis is marked as bad and not used. But as you can see, over the course of the 15 years, we've collected close to 120,000 samples. Of that, we've seen about 6% where we got some error codes back, and but if you start looking at what those error codes relate to, that number gets significantly smaller. And so a lot of the error codes are associated with this error code number 128, and that is related to conditions where you have very small high frequency waves, and basically the instrument is unable to unambiguously resolve the wave direction. So from an engineering standpoint, it's really not, these are not important periods because, like I said, they're very high frequency kind of ripples, very low magnitude, and the instrument is just not able to resolve that information carefully. So that if you remove that from your analysis, and then also this error code 2048, which is related to excessive tilt. And in this case, the excessive tilt occurred because on one of the deployments, the instrument got laid over on its side. And so the instrument, it recorded data, and we were able to get non-directional wave data out of it, but the directional information was not, because the instrument was on its side, we weren't able to get any data out of that. So if you take out the 128 and the 2048 error codes, you end up with the percentage of error codes on the order of 0.2%. So that's we've been really happy with our experience with the analysis and getting really good data out of the instrument overall over this time period. So just another thing I'll highlight is that when that center beam is trying to measure the surface, you'll have instances where it will run into errors either because of debris in the water, or it's unable to accurately detect the surface during a high wave event. And during a wave burst, the instrument will collect approximately 5,000 AST measurements or surface measurements during that 20-minute wave burst. And if less than 10% of those measurements or have errors with them, they can go ahead and process the data. But so one of the things we were concerned about was during high wave events, there would always been talk about that during these high wave events, you get a lot of aeration in the water, and that you would see the significant increase in the number of bad surface detects. And so we've kind of been plotting this over the years in terms of the wave height versus number of bad surface detects, and really do not see a real strong correlation or a real problem with the number of bad surface detects even during these high wave events. So that was just something we always kind of try to keep an eye on. I thought I'd hit some highlights of kind of our experience with the instrument over the years. And so overall, the physical performance of the instrument has been really good. They've held up well. We've had kind of minimal issues with the electronics. Biofouling has probably been the main issue, and we've had some issues with the oysters actually getting in. We're using the older style connectors, and you would have the little oyster spats get in between the plug, the connectors, and the cable where the cable plugs in, and then as it grew over time, it would dislodge the plug, and you would get water penetration into the and then you'd get corrosion, and then ultimately the instrument would the power would be lost to the instrument. So biofouling was a problem. Had a few problems with failed bulkhead connectors and cables. Fortunately, we have not seen much issue with pitting or damage to the transducers. We typically try to put some anti-fouling paint on them, and they've held up really well over the years. And as I said, the electronics themselves have held up extremely well, and we haven't seen any degradation in the signal strength over time. And just based on our experience, I was just going to highlight some of the maintenance recommendation we've come up with. So we've found that periodically replacing the cables and the connectors to be extremely helpful. And by that, I mean approximately every 2 years, just going out and putting new cables and bulkhead connectors on. If you're doing a long-term deployment, would consider upgrading to the Swaro connectors, and I'm sure I'm saying that incorrectly, but it's a higher grade connector that's now available, that is shown to be very robust and kind of avoid some of the problems we've seen. Also recommend paying close attention to the batteries and the battery connectors. When you get the batteries from the factory, we have run into a few instances where there was a bad crimp, or the cables had gotten crushed during shipping, and while they look good, you kind of start moving them around, and in the connection, you get a spotty connection. So we always do a real thorough inspection of the batteries and the battery cables, and then also load test all the batteries, because we have run into some instances where there's a bad cell in the batteries, typically damaged in shipping. And then just because of biofouling, we recommend you be highly aggressive in anti-fouling measures. Even on short deployments, we've seen it be a problem. And then kind of constantly be checking the hardware and the battery canisters for corrosion, because we have seen instances where you'll get a small pitting in the battery canister and then see very rapid erosion. We're using some of the aluminum battery canisters. So, and then in terms, I thought just quickly summarize how they've been using this data. I guess primary use has been using it as input into some of the numerical models that have been used to design some of the coastal structures by the City of Norfolk, as well as some of the beach renourishment projects they've been undertaking. And because they're able to, they've got better data to put into the model, they were getting better results, which ultimately, results in a better design decisions for the city and its structures. They've also been able to have direct measurements of the storm events, which allow them to go back and compare the performance of the structures to the design parameters that were used to in designing the systems, and so they can do kind of a really accurate assessment of how well the structures have performed. The data has also been used by other groups looking at developing some wave models for the lower portion of the Chesapeake Bay. As I said, the City of Norfolk, this was sponsored by them, and so over the past 15 years, they have constructed a number of projects with a value of probably by now well over $10 million, and this data has been a really important part of how those projects were designed. One thing that they found to be very useful was the fact that since they'd already collected the data, when they went to do a design, they could move forward very quickly without having to go do field measurements, which would delay the design process or the construction process. Like I said, they've used it on a number of different projects, and then they've also shared it with the Army Corps of Engineers and some other groups that have used it on various other projects within the Chesapeake Bay. And the value of those projects probably exceeds over to $40 million. So there's a lot of big projects going on in this part of the Bay, and having good data helps make sure that those projects are designed properly. And just here's some pictures of some of the different beach nourishment and breakwaters that were designed. It was also used in a study looking at dunes and dune overtopping during flooding events, as well as the City of Norfolk has a coastal storm risk program, and it was the data from the instrumentation was used to kind of help guide some of that work. As well as I mentioned, to optimize some of the some other larger scale wave models for the area. And then just in summary, the site-specific wave data has been extremely useful to the City of Norfolk. It's supported a lot of their construction projects, and the city itself sees it as an asset and an investment, and they have been very supportive of it over the past 15 years and seem very interested in continuing the support into the future. So it's something that I kind of see it as the poster child of what coastal communities should be doing, that having good wave data is worth the investment. So thank you for your time.
Awesome. Trap?
Yes.
There are two questions. David, if you want to ask your question, or I can read it.
Sure. Yeah, I'll ask it. Yeah, no, great presentation, Trap. Appreciate that. Very interesting topic. I saw, obviously there's a big disparity between sort of your average waves or heights over the years versus what you see during storm events. And I was curious that for the benefit of in particular here the City of Norfolk, is it better to track waves during the storm? Is it better to focus on the storms and get as much data from the storms, or are the more constant but smaller waves of greater importance? From an engineering perspective, kind of knowing the extreme events is probably, I guess, more critical. But like I said, all that's being used by Moffatt Nichol
we're not really getting involved in those type of design criteria requirements. So I would kind of have to defer that to Moffatt Nichol as to which they would prefer.
Okay, thanks.
Looks like we have another question from Jeremiah. This is actually a question I was curious about too. Do you recall the type of anti-fouling paint or patches used on the AWAC for these deployments?
We use actually just a transducer paint that you can get from West Marine, and we apply that, and then, as you may have seen in the pictures, the instruments were white, and that's because we use a paste to put on there that it's just a desitin. That's where, the desitin paste. So, which helps, it stays on for about a month and then wears off. But then the anti-fouling paint underneath is what helps for the next 3 months. So.
Right. Yeah, the first picture of the AWAC when you pulled it from the water was very clear. So that caught my attention as well. Seemed to be working.
Yeah. Yes. Yes.
Great. Let's see. I don't think there is anything else. Oh, you just had one more come in. Has the data collection completed, or is this continuing?
It is continuing, and we're currently under contract to go through the summer, and whether they'll continue to extend it or not, they determine on a year-by-year basis.
Awesome. There are